Okay, as I was saying before, you could be given a binary string of numbers just like this, be asked to convert it. They'll say, what IP does this binary string represent? And even if this is the only binary style question you have in the entire exam, these are points you want, even if it's 1 point. Could make the difference. There's no reason to give it away. These are gimmies. Easily done. Just crank through it like a machine, move on, collect your point or points, and forget about it. That's the whole idea. So, having said that, let us move on to a discussion of subnetting and some common questions. Things that you'll run into on the exam and in the real world of subnetting. So, to fully understand what you're doing with subnetting and why we perform subnetting, this is one chart we do need to know. Let me just type this out. Class A is what? That's 1 through 126. That's what the first octet is, with 8 network bits and 24 host bits. And then we've got Class B, which is 128 through 191. And it is 16 network bits and 16 host bits. And then we've got Class C, which is 192 through 233 with 24 network bits, 8 host bits. Now, at this point too, I'd like you to remember that anything beginning with 127, like 127.0.0.1, is reserved for loopback addresses, and it is the host. For instance, if you cannot ping 127.0.0.1, if you can't ping yourself, you have a very basic network issue there. TCP/IP probably is not configured at all. So we've got this chart down, and we know the network bits and the host bits, and I'll go and give you the network masks for them too. And these here, these are the default network masks, and for Class A it's 255.0.0.0, and for Class B it is 255.255.0.0. And can you guess what Class C is? 255.255.255.0. Now, we've got to have these values down because now we're going to build on this. But throughout the rest of this class, and in the future when you're on the job, you've got to be able to, when you look at an IP address, immediately say, okay, this is a Class A, B, or C, because it impacts the number of network or host bits that you have to work with. You must be able to identify it automatically. The number of network bits, whether it's 8, 16, or 24, simply indicates how many bits represent the network number when the dotted decimal number is converted to binary. Host bits are indicating how many bits are actually representing the host, and those values are really coming into play later. For example, let's take address 17.1.1.1. First things first. Let's take a look at it, just give you a visual. What class is that? A, B, or C? It is Class A. We also know we've got 8 network bits and 24 host bits, so we know right off the bat that the network portion is 17 and the host portion is 1.1.1. Simple enough. So let's revisit that chart and talk about why this is so important. Why do I need to know that there are 8 or 16 bits here? Why put such an emphasis on this? Well, that's where subnetting comes in. Subnetting is the process of borrowing host bits to create the subnet portion of an address. And the examples that we look at, the network portion never changes. The subnet is always borrowing from the host bits. And the key here is, why use subnets in the first place? let's face it, Cisco defaults are usually pretty good, so why bother to subnet? Well, let's look at an example of a point-to-point link. Subnetting is, by definition, a highly effective method of conserving IP addresses. But take a look at this. Here I have a choice in what network mask or subnet mask to use, a /30 or a /24. We've got a point-to-point connection here, and by definition, how many host addresses do I need for a point-to-point connection? I need 2, 1 for each end, right? There's no host in the middle since it's point-to-point, and that's why we call it point-to-point. So if we use an entire range for that network segment, that'd be a waste. And in a corporation, this is important. Let's say here I have a choice between a 24 or 30-bit mask. If I use 24 or 255.255.255.0, as you're going to see shortly, that yields 254 usable addresses, which is overkill and a lot of waste. If I use 30, that's going to yield 2 addresses, and that is all I need for this link. That's going to save us over 250 addresses. This allows a use of a tighter subnet mask than the default. So we're using one that yields a smaller number of addresses, and the IPs we're saving, they can be used in other parts of the network. Trust me. Go over this several times, and if it doesn't ring true yet, it will. Go through several examples, and it'll come clear. I just wanted to introduce you to the concept of why we subnet. It's a highly effective method to conserve IP addresses. We do this consciously by choice. Now, we're going to go over the question types that we're going to see in the exam and in the real world, and the first 2 of those are determining how many valid subnets we have with a given network number and mask, then the number of valid host addresses we have given a network number and mask. Now, when it comes to determining valid subnets, the formula, I kind of hesitate to use the word formula because it makes you think of something complex. This, again, it's not complex really. In the end, it won't be complex. The formula of valid subnets is 2 squared by the number of subnet bits. Now, if you studied for the previous versions of the exam in older days, Cisco used to have you subtract 2 from this. What they were saying was there were 2 invalid subnets in this. In the real world, that's not true. One of the subnets is IP subnet 0, and that one is commonly used. As a matter of fact, routers nowadays have that subnet enabled. So what happened is Cisco changed the rule, and they announced this, that you no longer will subtract 2 from this. I'm only mentioning this for posterity. It's just for your edification in case you run into an antiquated system somewhere. If you see the no IP subnet 0 in the configuration of the router, you subtract 2. You'll see this right in the top of the router config. It's there. You can't miss it. You see it all the time if you look at configs. If the routing protocol is classful, you need to subtract 2 from the result, and that means either RIP version 1 or IGRP. IGRP is off the exam now, has been a while, but I'm mentioning it just in case you run into an old system, because you don't see IGRP on Cisco exams at all. You might see it in real life, rarely. Old routers in a dusty corner somewhere working for over 10 years. Frankly though, you don't see it on routers anymore either. The only time you would subtract 2 is if you see the no IP subnet 0 in the config, or if the routing protocol is classful like RIP1 or IGRP. Cisco has made it clear that the questions, if you would be asked, you will know, and more likely it's going to be a CCIE style question anyway. Those are the people that are going to be asked something off the wall like this, not you. You should not subtract 2 if their classless protocols are in use, like RIP version 2, EIGRP, and OSPF. If those are in use, do not subtract 2. If you see VLSM anywhere, do not subtract 2, and you will run into VLSM if you're doing ICND2. They may mention it. It is a possibility. If you see IP subnet 0 command, you will see that it is enabled, so do not subtract 2. If Cisco does not mention it, do not subtract 2. If you actually see no IP subnet 0, or if routing is classful, you subtract 2. See the way that works? But in general, what I am telling you, you will never subtract 2 in reality, nor on your exam. I am simply informing you that in not that long ago, old days, it was something to consider. RIP version 1 is never used. IGRP is phased out by Cisco. New routers don't even support IGRP. It's possible only if you're a CCIE, really, maybe a CCNP. You're not going to run into it. It's not a major issue. I have beaten this to death, but I just wanted you to be clear on this old technology, just in case. So let's walk through an example of this and say the networks are presented with, we're given 172.20.0.0 and a subnet mask of 255.255.255.0 or /24. And we'll go over slash notation soon. You will know what that is in a minute. We've got to know what class this is because it'll tell us how many host bits and network bits we've got to work with. Then we've got to see how many have been borrowed. Here, let me get this out of the way. And the /24 is the same thing as 255.255.255.0. So first off, we know class what? And this would be a class B. So our default mask for this is actually 255.255.0.0. Class B default. So what is this in binary? That's easy because as soon as you see 255, you know that all the bits are set to 1 on that. And if you add up all those bits, 128, 64, 32, 16, 8, 4, 2, and 1, that is 255. That's why we run into 255 so often. That's the maximum number in binary for an octet. So if you've never walked through this before, you're going to see this a lot. You're going to know immediately that a default Class B subnet, or Class B mask is, whoops, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. And 1, 2, 3, 4. That is the same thing as that. Same thing. So is this. And you thought that binary math was going to be hard. You're going to, you see this, you understand this, just like you're a champ already. All you need is a little practice. But just in case you don't have this question that we're leading up to already answered, let's write out the subnet mask. And the subnet mask is, in this case, 255. And in binary, of course, all those ones. So remember that I said that subnetting is the process of borrowing host bits. So we need to identify where the subnet bits are. There's a reason I drew both of these masks out for you.